Hi everyone, Assalamualaikum. In this video, we are going to discuss partial derivatives of three variables. Now we look at example 1. For the function f x y z equals to 2z cubed minus 3z times x squared plus y squared, show that fxx plus fyy plus fzz equals to 0. Alright, from here we have fxx, fyy, and fzz. So first step, we need to find fxx. But before we find fxx, we need to find fx first. Alright, fx means we differentiate f with respect to x. Okay, if we differentiate with respect to x, means we treat x as a variable. Okay, and we treat y and z as constants. Right? So to find fx, we differentiate from f. Okay, so from f equals to 2z cubed minus 2z times x squared plus y squared here, we can write variable x in different colors. Okay. Alright, from here, we can expand first. So when we expand, we have f equals to 2z cubed minus 3z x squared minus 3z y squared. Right? Alright, now we treat y and z as constant. So z here is constant, z cubed is also constant, times 2 is also constant. Okay, z we treat as constant, so times constant equals to constant. Okay, z and y here we treat as constant, and then times 3 here means also constant. Right? And then when we differentiate any constant, we get 0. Okay, this is also constant. So when we differentiate constant, it becomes 0. Okay, when we differentiate constant alone, we have 0. But here, we have multiplication by constant. Okay, so we need to keep the constant in front after we differentiate. Okay, so after that, we differentiate x squared with respect to x. So we get 2x here. Okay. Remember, if we have constant only, when we differentiate, it equals to 0. But when we have multiplication by constant, means constant times variable, we need to keep the constant in front after we differentiate. And we just differentiate the variable, means we just differentiate x squared, so we get 2x. Okay, and then we keep the constant in front here. Right? After that, we simplify, so we get fx equals to, we multiply here, so we get negative 6xz. Okay, this is our fx. Right? Right, and then from fx, we can find fxx. Okay, so fxx here means we differentiate fx with respect to x. So since we differentiate with respect to x, so we treat x as a variable. Okay, and then we treat y and z as constant. Now we have z here, so z is a constant, so times constant equals to constant. Okay, and then when we have multiplication by constant, okay, we just keep the constant in front and then we differentiate x. When we differentiate x, it is equals to 1. So it means negative 6z times 1. Okay, which is equals to negative 6z. Alright? Right now, we find fxx. Okay? Right, after that, we can find fyy. To find fyy, we need to find fy first. Okay? Fy means we differentiate f with respect to y. So we treat y as a variable. And then we treat x and z as constant. Okay. To find fy, we differentiate from f. Okay. So f equals to 2z cubed minus 3z x squared times x squared plus y squared. Then we can expand first. So we get f equals to 2z cubed minus 3z x squared minus 3z y squared. Okay. Alright, now we treat y as a variable. So to avoid error and easy to differentiate, we can write y in different colors. Okay. Alright, so from here, we have variable x and z as constant. So from here, we have z. So this is constant. Okay. Z and x are constant. So it means this is constant. Okay. And then here z is constant, y is variable. Okay. And then we can find fy. When we differentiate constant, it equals to 0. Okay. And then from here we have multiplication by constant, means constant multiplied by variable. So what need we do is we just keep the constant in front. And then we differentiate variable y. So when we differentiate variable y, it is equals to 2. When we differentiate y squared, so it is equals to 2y. Okay. And after that, we simplify. So we get fy equals to negative 6yz. Right. So this is fy. We done find fy from the previous slide. We still under step 2. Okay, now we can find fyy. Okay. To find fyy, we differentiate from fy. Okay. Alright. Fyy means we differentiate fy with respect to y. And we treat y as a variable. Since we treat y as a variable, so we can write y in different colors to avoid error and easy to differentiate. Okay. Alright, at the same time, we treat x and z as constants. Okay. When we differentiate fy with respect to y, so the symbol is fyy. Okay. Then we get the answer negative 6z. Okay. Why we get this? Because negative 6z is a constant. Okay. Remember, we treat z as constant. So, constant negative 6 times z constant equals to constant. Okay. So, now we have multiplication by constant. Means constant times variable. So, we just keep the constant in front after we differentiate. Then we differentiate y, because y we treat as variable. So when we differentiate y equals to 1. So it means we have multiplied by 1 here. Okay. Or the other method, we just imagine. Okay. Let's say we want to differentiate 3y with respect to y. Means we assume negative 6z equals to 3. Okay. So when we differentiate 3y with respect to y, we get 3 here. Means that when we differentiate constant y with respect to y, so it is equals to constant. Okay. Alright, now we done find f, y, y. Okay. So after that, we can find f. So after that, we need to find f, z, z. Okay. So step 3, before we find fzz, we need to find fz. Okay. Fz means we differentiate f with respect to z. Means we treat z as a variable. And at the same time, we treat the other variable x and y as constant. Okay. To find fz, we differentiate from f. Okay, f equals to 2z cubed minus 3z x squared times x squared plus y squared from here. Okay, before that we can expand first. So we have f equals to 2z cubed minus 3x squared z, and then minus 3y squared z. Okay, and now we treat z as a variable because we want to find fz. So to avoid error and easy to differentiate, we can write variable z in different colors. Okay, and we treat x and y as constant. So here we have x squared here, so means this is constant. Okay, and we treat y as constant, so means 3y squared here is a constant. Okay, alright, then we can differentiate f with respect to z, means the symbol is fz. Okay, and then to differentiate 2z cubed, z we treat as a variable. Okay, we just imagine from here we want to differentiate 2z cubed with respect to z, so the answer is 6z squared using power rule. Okay, that's why we get this. Okay, and then to differentiate constant z here, we can imagine, let's say we want to differentiate 4z with respect to z, so the answer equals to 4. So that's why when we differentiate constant z here, it means 4 here is a constant. Okay, so when we differentiate constant z, the answer equals to constant. Okay, and same goes to 3y squared z. Okay, when we want to differentiate constant z, so we have constant here. Okay, we refer from this. Okay, alright, so after we find fz, so we can find fzz. Okay, fzz we differentiate from fz. Okay, so after we differentiate fz with respect to z, so we get the symbol fzz. Alright, before that, fzz means we differentiate fz with respect to z, means we treat z as a variable. At the same time, we treat x and y as constants. Okay, so means x squared times 3 here is a constant, and then 3y squared here is a constant because we treat x and y as constant. Okay, then to differentiate 6z squared, okay, we just imagine. Okay, now we want to differentiate 6z squared with respect to z. So using power rule, we get 12z. So we get this. Okay, and then to differentiate constant here, we imagine we want to differentiate any constant with respect to z. Okay, the answer is 0. So that's why we have nothing here. Means minus 0 and then minus 0 here. No need to write. Okay, so our fzz equals to 12z. So now we done find fzz. Okay, alright, so we can continue with step 4. We can show that left hand side equals to right hand side. Okay, so from here, from left hand side here, we have fxx plus fyy plus fzz. Okay, from here. Okay, alright, from the previous slide, we get fxx equals to negative 6z. And then we get fyy equals to negative 6z. Okay, and we get fzz equals to 12 z. Okay, so we substitute here. Okay, so from here we have fxx plus fyy plus fzz equals to negative 6z minus 6z plus 12z. Okay, from here. Okay, negative 6z and then plus and minus, we get minus, and then plus and positive here, we get plus here. Okay, and then after that, we have negative 6z minus 6z plus 12z. After we simplify, we get 0 here. Okay, then we can compare. Okay, from the given question, we want to show that fxx plus fyy plus fzz equals to 0. So from here, we done show fxx plus fyy plus fzz equals to 0. Okay, so it's shown, right? Coming up next, partial derivatives of three variables. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.